Okay, off camera I pulled this apart, which you might remember I stuck it over behind me because it was in the way. Now it took a bit more to get apart than what it should have, and it's quite obvious. Actually, just tilt down a little bit. It's quite obvious once we got it off as to why, and quite frankly I suspected as much when it didn't come off as easy as it should have. When we look at the shaft, we can see this damage to it. Hopefully you can see it well enough. There we go. So what's happened here is that square-headed bolt, or square, this one here, engages on the shaft, the one that you can't see. Let's zoom out again. Okay, this one here, this square-headed screw here, lock screw, engages on the shaft. Problem is it hasn't been done up tight enough, so it's rotated on the shaft, or slipped on the shaft, and it's damaged the shaft. Now the problem that I now have, I won't say the problem I have, the result issue of that is, when we zoom in, and we get it in the right, the camera in the right spot so you guys can see. There we go. There's a score in the bore here, and that's the bad one, and there's a lighter one on this other side, if I can get the light right, which you might have a bit of trouble seeing. But basically there's one here and another one here. So there you go. So what I'll do with these, that'll just stress out. The shaft I'll probably take to with I think I'll take to the shaft with an oil stain. Take to the shaft with an oil stain or something. We'll knock that off, and then what I'll probably do when I put it back together, or I might even do it before I put it back together, because I know exactly where that's got to be, because I've got a witness mark. What I might do is I might just put it in the mill, and I might spot this so that it's down 2 mil, 3 mil, so that when we get that in, get it in the right spot, tighten it up, it can't slip. Then we won't have the problem again. Incidentally, when it came to taking this off, you can't just press on it or bash it or whatever. What I did was very careful to put the press plates on this face, or to support it on this face. Even if you're going to hit it with a hammer, you need to be supporting it on this face. If you're supporting it on the outside ring, the probability is you're going to have a 2 or 3 piece pulley, because the chances are it'll break. They're cast iron. There's no provision for lubricating these bearings, so basically you grease them up, and when they fail you throw them in the bin. The amount of grease they didn't have in them, this machine couldn't have done much work at all. So yeah, alright. What we'll do now is we'll, it won't be today because I've got to go out, but what we'll do next is we'll prep it, grind it, preheat it, and then we'll do something about welding it. Welding will probably be brazing, I think. The more I think about it, the more I'm inclined to braze it. And as I haven't got the oxy handy, what I'll probably do is I'll probably preheat this in the barbecue, stick it in the gas barbecue, the old gas barbecue, and heat it up, preheat it in that. And then what I'll do is I'll probably try TIG brazing it and see how I go. So yeah, see you later. Well, what we're doing today is we're going to try TIG brazing some cast iron to repair the shaper that I've got. We're currently doing a bit of preheating at the moment, as you can see. I hope you can see. We're doing a bit of cooking in the barbecue. So what we've got there, I'll grab a couple of others. This is the next one I've got to do. Basically, that is meant to join onto there, and that one's broken. The other one's got a drill hole in here where a support comes off for the belt guard. Comes right through the centre here, and that's broken through there, so we've got to repair that bit. We'll brace this back on. The reason that we're using the TIG is because I haven't got an oxy. I've got an LPG torch which we're going to use to put a bit more heat into it before I start the TIG, so that we get some more heat into the area that I'm brazing. I want to get more heat into that again, but at the moment we're just building heat. We're going to see how we're going. We're going to use a manganese bronze. While we're waiting for this to warm up, you'll notice this. I don't know if you can notice, but there's a fair bit of smoke coming off it because it hasn't been used for a while. I'm running it in preheat mode and trying to get it up to at least 200 degrees centigrade, which is about 400 Fahrenheit. And then what I'll do is I'll actually let it cool down in there as well. It'll probably cool down quicker than what we'd like it to, but yeah, we've got to make do with what we've got. So we'll see how we go there. It'll be an interesting experiment to see how it goes anyway, considering I haven't, I've never TIG brazed before, and there's going to be a bit of suck it and see involved. So I've seen it done on YouTube, but I've never seen it done quite like this. I've seen them when they're TIG brazing. I haven't seen them do cast iron. And this is a structural part. It's got to hold up a 3-phase electric motor. It's only 1.5 horsepower, so it's not a big motor, but we still got to hold it up. So yeah, we'll see how we go. Well, we'll turn that down to low for the moment. That's out of just for your information, that was about 280 degrees on the one that I fixed first, or that I brazed first, and it was about 400 degrees on the second one. The